So here's a quick example where they're asking us to find the Thevenin equivalent circuit, and that's going to be between these two terminals. So we're going to be dealing with everything to the left of the terminals, and we see here that we have a independent current source, and then we have a dependent voltage source, which is dependent on this current IX flowing through the 10 ohm resistor. So let's see what we need to do to find the Thevenin equivalent circuit. So the first thing we want to do is by observation, we see we could do a quick source transformation. So anytime we have a current source, such as this 10 amp source in parallel with this 5 ohm resistor, we can transform that into a voltage source in series with the resistor. And so when we do that, we just multiply the two to get the magnitude of the voltage source and keep the resistance the same. So in order to do that, we can come back here and modify this circuit then. And so this then would become a voltage source. This would, instead of being in parallel, will now be in series. So let's draw that. So this resistor is now in series. Remember, it was 5 ohms. And remember, the plus sign goes in the same direction as the current flow was, and the magnitude we said was the product of the two, which this was 10 amps and 5 ohms, so this will be 50 volts. So now this is our new circuit. Still, as far as the two terminals are concerned, nothing has changed. It should measure and behave to the left of those terminals just as it did before. The source transformations are equivalent. So the first thing we see that this does for us then is we can define this mesh current, but this mesh current is now just IX, because IX now goes through everything because it's just a single loop. So this being the case, we should be able to solve for IX. And so we can do that by just doing the loop equation and summing up all the voltages. So in this case, we'll put the voltage sources on the left side of the equation. So the first thing we have is this 50 volt source. And so we'll just write that here, 50 volts. And the other voltage source we have then would be this dependent source here. And the dependent source is just 5IX. So then we will say plus 5IX. So that's all our voltage sources. And so we're going to set this equal to our voltage drops, which would just be the two resistors. And so in this case, we'll have the 5 ohm resistor here. And that's just going to be the resistance times the current. And we know both of those, the resistance is 5 ohms, the current is IX. And then finally, we have our 10 ohm resistor here. And same thing, it's just Ohm's law, voltage times current, or resistance times current, excuse me. So that'll be, again, 10 ohms times IX. So here we see we have one equation, one unknown. So it's just a simple algebraic solution. And so when we do that, we should see pretty quickly that IX is going to be equal to 5 amps. So that's IX. And now from this, we should be able to get our open circuit voltage. So that's our voltage across our terminals. So going this way, what is the voltage across here? So this would be the voltage we'd get if we were to put an ideal voltmeter, that is infinite resistance, no current flowing through it, voltmeter. So what would we get? And so that'll just be, we can define it here, our open circuit voltage is just equal to, again, Ohm's law, IR, which in this case it's IX times 10 ohm resistor. So that's 5 times 10. So that's 50 volts. So 50 volts is our open circuit voltage. So that's half of what we need for the Thevenin equivalent. Remember, Thevenin equivalent is what voltage source in series with what resistance can we replace between those terminals that behaves just as the circuit does. So next thing we need to find then is our short circuit current, because if we have that, then we can use that to find our Thevenin resistance. So now we'll come back to our original circuit here. Let's reset this. And let me just do a couple of housekeeping things here. All right, so here we have our circuit here. So to get our short circuit current, and let's draw a line here to show that we're working on something different here. So in our short circuit current, that's where we take just a wire and short this out. So we just short these terminals out, and then we measure what current flows in this short circuit. That'll be our I short circuit. So in this case, this 10 ohm resistor is totally shorted out. So there'll be no current flow here because it's shorted. So in that case, it would be as if it wasn't even there. So it's gone. So now, since there'll be no current flow in the 10 ohm resistor, that means that Ix, the current flowing through it, will be 0, which in turn means that this voltage source will always be 0. So this is getting pretty simple by the minute. So now we can just eliminate this totally. It'll be just like a short circuit. So anytime you have a 0 voltage source, that's just a short circuit. So we can short that out, and then we can say the Ix is no longer a factor here because we've shorted it out. So then, that being the case, this is all that we're left with. And so now we should be able to calculate this current pretty easily because it's just a resistor and a voltage source. So we can calculate that pretty easily by saying that I short circuit is going to be equal to, by Ohm's law, the voltage over the resistance, which in this case we have 50 volts over 5 ohms. So that is going to mean that I short circuit is 10 amps. So now we have our open circuit voltage, our short circuit current. So now we can calculate our Thevenin resistance. So our Thevenin resistance, RTH, that's going to be equal to, again, by Ohm's law, it's V over I, so which in this case, it's our open circuit voltage over our short circuit current. That's the definition of the Thevenin resistance. So we know our open circuit voltage, we calculated that as 50, and our Thevenin resistance, we calculated as 10. So that means our Thevenin resistance is going to be 5 ohms. So then these two values here are what we need to create our Thevenin circuit. And so we can do that up here. So then if we reset our circuit here back to the way it originally was, like this, then we can say then that our equivalent here between these two terminals would be a 50 volt source and a 5 ohm resistor, and that's the same two terminals as we defined over here. So this is our Thevenin equivalent for this circuit.